So here we are, similar triangles. Similar triangles are triangles that are exact same size, but one is either bigger or smaller than the other. It's like, right? You know how you can draw something and then take it, ooh, these are all similar. Oh, that one, oh, now it's not. This is not similar if I do this, but if I just carefully enlarge it, that would make that a similar triangle. Some facts about similar triangles. 1, the corresponding angles are equal. So if I go back to this triangle, that means that this angle here corresponds to this one. And those two angles would be identical. This angle B looks like a 90-degree angle. It corresponds to F. Would also be a 90-degree angle. And angle C would be equal to angle G. So I'm going to just show you some notation here. Okay? I'm going to show you that you could say angle C equals angle G. That would be the easiest way to talk about an angle. Just use the letter that's corresponding to it. But sometimes when you have a bunch of lines, you get to notation like this. And so how do we do angle C with 3 letters? Well, if I wanted to do angle C with 3 letters, I imagine taking a pen and saying, I want angle C. So if I start at A, then go to C, and then go to B, that makes angle C. So I would write that as angle starting at A, go to C, then to B. Whatever letter is in the middle corresponds to that letter that's all by itself. So ACB is equal to angle, same thing over here. If I want angle G, I'd have to go EGF. And that G would be in the middle. So those are 2 different ways to label angles. Which way is nicer? Obviously the first way. If you have a simple triangle, and you want to talk about angle C is easy. But sometimes you might have this. Draw a picture. Triangle there, A, B, C, D, and someone says, I want to talk about this angle. If I just say angle C, the person's like, ooh, did you mean just this little one? Did you mean just this little one? Or did you mean them both together? What's angle C? So if I wanted to talk about just that green one, the only way I'd say, okay, I can start at B, then go to C, and then go to A. That would be that green angle that I'm labeling. So there's a reason why we use 3 letters, but if you don't need to use 3 letters, just a single letter for an angle is easier. So fact number 1 about similar triangles, corresponding angles are always the same. Fact number 2, corresponding sides are proportional. So what does that mean? Well, if I find out the distance from A to B is 4 and E to F is 2, can you see that the bigger triangle is twice as big as the smaller one? So if this side is 3, that would mean this side is 1.5. And if this side is 5, this side would be cut in half, 2.5. And what it means by the ratios is if I would take AB and divide it by EF, 4 over 2, I get 2. If I take the hypotenuses and divide them, 5 divided by 2.5, I get 2. And if I took the bottom sides and divided them, 3 divided by 1.5, I get 2. So similar triangles have as a second key concept, the corresponding sides are proportional, and the number by which we increase or decrease the sides is a scale factor. And that's why this is in this unit and how it's connected. Right? If I was going from this triangle to this triangle, I'd have to multiply everything by 2. So I would say, going from the small one to the big one, my scale factor is 2. If I went from the big one to the small one, excuse me, I'd have to multiply by 1/2. So then I would say my scale factor is 1/2. Okay. Are these triangles similar? So if they're similar, are the corresponding angles the same? This one's 90, this one's 90. Check, check. What about this one? Are these angles the same? 32, 32. Yes. And finally, hey, do you know how to find the other angle in a triangle if you know 2 of them? That's something. Oh, I'm talking about the angles. How do I know, looking at this diagram, looking at the numbers that are there, that the final angle, and of course this is not drawn to scale, but that's okay. How do I know that that final angle should be 58 degrees on both of them? How do I know this is 58 degrees, very bad scale drawing, and that's 58 degrees? What do the angles in a triangle add up to? This is a very important fact about triangles. Something you learned in middle school. How many degrees does an angle in a triangle add up to? All the time. Need a hint? Rhymes with abundant and Beatty. 180. Wow, you are amazing. 180 degrees. So if I wanted to find this, I would say, well, 180 is everything. If I subtract the 90-degree angle and I subtract the 32-degree angle, I'm left with 58 degrees left. That's how I figured out that the angle at the top is 58 degrees. So are they similar? Yes. If you can see that all the angles are the same, they are similar since corresponding angles are the same. How do you go from here to here? What's the scale factor? What do I have to multiply to go from 3 to 9 or from 4 to 12? You have to multiply by 3. So it is a similar, they are similar triangles. Ooh, I like this. Sorry, I'll make this bigger so we can see it better. Ooh, I just made similar triangles as I made it bigger. You're given this information. So the first thing you're going to do with given information like that is you're going to label it on your triangle. Angle ADE is 60 degrees. So where's ADE? That would be this one right here. Okay? A to D is 4. A to D is 4. I've done the first two for you. I'm going to give you a head start to label the other 5 things left. See if you did the rest right. Let's see. AED is 58. Did you label the 58 in the right spot? FBC is 62, so that would be 62 here. A to E is 3.8. F to C is 10. And D to E is 1.7. Okay. And now we have to label everything that's missing. So I'm going to change colors. I'm going to change to green. If these triangles are similar, we know that the corresponding angles are the same. So that means if the top one's 62 here, the top one's 62 over there. If this one's 60 there, this one's 60 here, and this one's 58, that one's 58 degrees there. So the angles are this super easy part in similar triangles because they're all the same. The harder part is finding the sides. But if you take one of the sides, I'm going to take this 1.7 and I'm going to take this 10 because those are corresponding sides. And I'm going to go from 1.7 to 10. I have to figure out what do I need to multiply by to go from 1.7 to 10. Well, I take out my calculator and say, well, if I take 10 and divide it by 1.7, I'll figure out what I need to multiply by. 5.88235291. Wow. So I'm multiplying by 5.88 to get that side. So if I want to find this side, I have to take 4 and I need to multiply it by 5.88. So go to my calculator. 4 times 5.88 equals 23.5. So I now know that this side is 23.5. Did I round correctly? Yes, I did. And this side, which was 3.8, I take 3.8 and multiply it by 5.88. 22.3. And now I found all the missing shapes and sizes. I mean shapes, size, all the missing angles and all the missing sides. Are the following triangles similar? Okay. Now, if you just looked at the shapes, they look and appear to be similar. But they're not because how do I go from 5 to 10? Times 2. And 3 times 2 is only equal to 7 if you make a mistake. Right? This actually is multiplied by 2.33. No. They are not similar. Since the scale factor is different. Sometimes your scale factor triangles become difficult. This is one of those examples. Okay? What this example is expecting you to see is which triangles are similar. Well, can you see that I have a big triangle in this question? I'm going to drag that off to the side here. I'm going to put the big one here. Can you see that I have a smaller triangle right here? I'm going to drag that there. Can you see that on both of these triangles, the blue one, we have 90 degrees there. The green one, we have 90 degrees there. Does it make sense that this angle in red, which is this one, is the same on both ones because it's in both triangles? And if you have two angles that are the same, because they add up to 180, that third angle will also be the same. So these two triangles, because all the angles are the same, are similar triangles. Now if I label, what do I know about these triangles? I know that this length on the green one is 10.2. What is the length on the blue one? there. It's not super tricky. No, the blue one. Here, I'll drag it back. There it is. There it is. I want to find this bottom side on the blue one. 17.2. Good work. It's not super tricky, but it made you think. You have to add those two together to get 17.2. Now, what do we know? We know that this side is 5.4, and we want to figure out what that side is. So what do we notice? If they're similar triangles, you're going to be multiplying by something to go from 10.2 to 17.2. You're going to need a calculator for this. To figure out what I need to multiply by, well, I could go 17.2 divided by 10.2, 1.686. I'm multiplying by 1.686 to go from here to here. So if I want to find x, I need to multiply 5.4 times 1.686. $9.1. And there is our final answer. Pretty cool. Because looking at the diagram to begin with, it looks like it would be really hard to figure out that x. The mathematics seems difficult, but once you know how similar triangles work, it's actually not too bad. Okay, we have two more questions. There's a statue, Golden Boy, named, I don't know, can't think of a single name for a golden boy right now. Anyways, we've got a statue of a golden boy, 8 meters tall. It casts a shadow 3 meters. So first of all, I'm pretty impressed with my drawing there. Oh, that's yellow. Can you even see that? So we've got our statue, 8 meters tall. So let's label this from here to here is 8 meters. Okay, here's the sun is over here. Casts a shadow on the ground 3 meters. Oh. At the same time, oh, wait for it. This is going to be awesome. Just wait. Wait for it, wait for it. There we go. At the same time, there is a person who will not be named. There's the person, 1.5 meters. Is that Logan? Maybe. He's not here to defend himself. Okay? That same sun made a shadow of 0.6 meters on Logan. How tall, not Logan, like just a random person. Not saying that that looks at anything like anybody in this class. Just making sure. Okay. How tall is this creature, we'll just say, from now on? Well, because it's the sun, it will make the same triangle. It'll make the same angles. And so these triangles are similar. And then we look, what would I have to multiply by to go from 3 to 0.6? Well, I take out my calculator and I say if I take 0.6 and divide it by 3, not multiply, divide it by 3, I get 0.2. I'm multiplying by 0.2. Do you know what is crazy? This is the most exciting thing that's happened to me all day. Okay? How tall did we figure out this creature was actually earlier in the day? 160 centimeters, which is how many meters? 1.6 meters. So now, this was meant to be, we take the 8, we multiply it by 0.02, or not 0.02, just by 0.2. We go to our calculator. This is so exciting. 8 times 0.2. 1.6. Whoa. Whoa. Okay. So we can now say the creature, because we're not going to name any names, is 1.6 meters tall. That's awesome. So one more for you to try, and then I'll put up the answers in a bit. The sun is casting a shadow along the ground from a tall tree. The shadow is 22 meters. Bob notices his own shadow is 2.4 meters. His height is 1.75 centimeters. The thing you need to know for that is you should have the same units. Oh, you just missed the most amazing result. Okay? This question had a golden boy statue in it, which was not named. Okay? And then there was a person in this question, which we did not name, but did have resemblances to someone in class. Okay? We did the math, and the answer to the question of how tall the creature, because we didn't name the the actual answer was 1.6 meters. And that's exactly how tall you were. Which is just crazy. Okay. There's Bob, not resembling anybody in our class. Shh. Okay. Bob happens to be 1.75 meters tall, and his shadow is 2.4. So we go, if you want to go in this direction, 2.4 to 22, we'd have to multiply by something. How do we figure out what we want to multiply by? 9.16. You need to multiply by 9.16. If you went backwards, you could do that as well. But the reason I'm going this way is because I want to go this way to that one. And so I'm going to need to multiply by 9.16 for this as well. 1.75. Am I round? Oh, it should be. Let me add. I should round correctly. I'm going to change it to 1.9. 9.167, because it should be rounded up. So I take 1.75. 1.75 times by 9.167. 16.04. And everything is in meters, so I put meters as my final answer. This is really powerful, because if you know how tall you are, right, you can measure your shadow anytime. And then you can measure the shadow of any building and figure out how tall that building is. The only hard part about measuring your shadow is you see it on the ground, then you bend down to measure it, and just like it moves on you. You're like, ugh. So you stand back up. Okay, there's my shadow. It's like so frustrating.